I spent a lot of time at Wells's textbook, and I will say it's pretty much error-free. There are some errors in it, but for the most part, remarkably good. This is one problem in particular that, although he doesn't put any work down, they did put the incorrect answer down, right, for the problem. Just a simple answer. They put the wrong answer down. I'm not worried about that. What I'm worried about is how would I attack the problem and how would I verify it's correct or not. So what I want to do is I want to talk about what I would do, or what I did do to solve the problem. So what I did was I squared both sides of the first equation and of the second equation. Now there's some confusion, but I do want to go through that with you. And there's also a point of possible error when I do this. What I mean introducing an error. Whenever you square a root, you could introduce an error into the problem. Now, if I were to do this, what I'd get is I get x minus y squared plus xy plus 2 x minus y root xy. All right? Then what do you get? By the way, this could introduce an error. I'm not worried about that. We'll talk about that later. Over here, you get x squared. Let's see, minus 2xy plus y squared plus xy plus, I'm going to distribute this now. So it's going to be 2 x root xy minus y root xy. All right, now I can simplify this a little bit. I get x squared minus xy plus y squared plus 2. And this is kind of a tricky thing to do. We bring the x on the inside. And what does that give me? That gives me x squared y minus, I'm bringing the y on the inside, so I'm sorry, that's x cubed. It's x squared times x, my error. Again, when I bring the x on the inside, it's x squared. There's already an x there, so it's x cubed. Sorry about that. Minus, I'm bringing the y on the inside, and that's going to be y squared, so it's y cubed. All right, so I want to tell you where this is. This is written right over here. All right, right over there. I got everything I need. All right? Okay, let me erase this, and I'm pretty comfortable that I have something here. All right, so then what do? I'm looking at this, and I'm saying that sure does look familiar to me. And what is it? Well, looking back over here, it's just the number 30. All right, so that's just the number 30. So I just put it in there. And then what I do, I kind of rearrange it. And I'm not saying it gets any better, but I certainly don't have any roots in the problem anymore. So I rearranged it. 2 times 30 is 60. Take it from 121, add xy to both sides, and I get this. This is important, right? I do the other equation. I also square that one. Relatively simple to square this. What are you going to get? I'll write this down. You'd get x cubed y plus x y cubed minus 2 root. Well, that's going to be, just multiplying it out. And there is problems with what I'm doing, by the way. I realize I'm not even thinking about what the letters mean. But what do you get over here? You get x4, y4. And so you get x cubed y plus xy cubed minus 2x squared y squared. And certainly 30 squared is 900. And that's where this is coming from, right over here. I'm expecting that, all right? Let me get my eraser out. Let me get this over here. I'm done with that. And then what I did was I start realizing, I see that x squared y squared. And I factor the xy out, and I get this over here. These are two important things. So what are you going to do now? I got to start making replacements here. So what I do, I'll outline this for you. X squared plus y squared, I see that there. Same thing as that. So I just make a substitution, and I get this over here. Then, of course, what do? You multiply it out, and you get a quadratic in xy, which is factorable. I get this over here. All right, so this is where, everything boils down to a really simple statement. Let me get my eraser out. And this is a long problem. Don't think you're done yet. But I do know, looking at this, if everything followed along nicely, I do know xy is equal to 25, and I do know xy would equal to 36. Zero product rule, so to speak. right, what do you have to do now? Well, you got to plug it in somewhere. So my claim over here, where I would plug it in, is the simplest equation I could find that relates things together. So I'm going to say it's probably this one over here. Right, so it's not easy, but you're going to plug it in. Now, what does that mean? You're going to take this, and you're going to plug it in. And what would you get? Well, you get x minus, I want to get in one letter. What would y be? It would be 25 over x. And then what do you get? Plus, well, it's the root of 25, which is 5, equals 11. Then you multiply, well, you know what I'll do? I'll get this x minus 25 over x minus 6 equals 0. Multiply both sides by x, you get x squared minus 25 minus 6x equals 0. Oh, that's probably pretty interesting, isn't it? What do you get there? X squared minus 6x minus 25 equals 0. And what you have to do there is use the quadratic formula. So on this, can't factor using finger numbers, I could write down what x is, though. What's x? And I can imagine back in Wells's time that this was typical for what someone was doing, a lot of hand arithmetic, right? I'm going to do some. I'm not going to do all of it, by the way. And there's a point to it. It's a long problem. It's not over. It's nowhere near over yet. But twice a, which would be 2, that would be 6, plus or minus, let's see, 36, minus 4ac, which would be plus 100. And this would be x equals 6, plus or minus 136 over 2. 136, well, 2, that would be 68, right? 120, yeah. And 2, and then you get 34. Oh, that's not so bad. So you get x equals 6 plus or minus 2 root 34 over 2. Divide through by 2. You get 3 plus or minus root 34. So I get two separate x's. And I want to tell you where they are. One is here, and one is there. And then what I did was I just plug it back into a simple fact that xy equals 25. Now granted, you do it, and if you do the work, you get these numbers over here, right, if you do the work. Now, I'm going to say if you do the 36 and you plug it in here, it's going to yield 2 points, which are really simple points. So I have 4 points. And this is where I think for the most part people would say, oh, I'm done. I'm not going to do anything else with it. But there's a problem. And so I'm going to start talking through the problem. And I have tools that Wells did not have at his disposal. The problem is as follows. By doing all that squaring and stuff and putting things in roots, taking them out of roots, I've introduced solutions that are not there, all right? So of these 4 points that I just listed for you, 1, 2, 3, 4, only 2 of them worked. This one and this one are the only 2 that worked. So what I want to do is I want to do the graph, and these are tools that Wells did not have at his disposal. And I looked at the graph. Let me go to the graph. And what I see is I believe I see 2 of those solutions, right? Right here. Let me get my ruler out. And I'm going to just do this over here. I'm seeing the 9, right? So I'm going to write that down. This one here, just by using my rule, it looks like 9, 4. Did we say that was an answer? Look how long that is, right? Yep. Now the other one, I want to point out over here, it's complicated. I'm not saying it's the easiest thing in the world to look at, but I'm going to say, roughly, it's a little bit below 9. So I'm going to say like 8.8, let's say. And over here, what's this one over here? I don't know. It's 2 points on. I'll get 2.8. I'm ballparking it. All right. So let's take a look. And let me get my ruler out again. I said that this one here, the other one, was a little bit below 9. I do see that. And then I said about 2.8 for the, let me get my ruler back. Yeah, I'm seeing it. So this is the other one. Remarkable. It's there. I can't remember what that point is, right? That was 3 plus root 34. See how long that problem is? Minus 3 plus root 34. But you know what? If you graph it out, you also see another one way over here. What happened? It's weird, right? All that work we just did, squaring them, taking letters that were outside the roots and putting them inside the root, yada, yada, yada. This is where I think it really, you should be sort of careful when you do things like that. But I gotta be honest with you, sometimes you're so exhausted you can't be careful. You get sloppy, all right? So I'm gonna say over here, however, you should look at the graph and notice we're missing a point of intersection. Let's try to find it. So the one thing I'm pointing out over here, and again, we certainly are encouraging you to read, you should be aware that the process of squaring both sides of an equation may yield extraneous solutions. Looking at the two equations, it should be clear that either x and y are both simultaneously negative or simultaneously positive. All right? If they're both negative, the system simplifies too. So you know what happened? I'm missing this one over here because I need to make that assumption that both are negative. Over here, both x and y are positive numbers. Over here, both x and y are negative numbers. All right? So let's go back. And again, I know this is going on for a long time, by the way. And what I did over here, whoops, I got to do it, right? Where are we? Let me erase this business over here. We're done with this. We did this already. Let me see if there's anything else I need to say about this. Let me erase this here. Okay? So let's go back to the original system. A lot of scrolling here, wasn't there? Okay. If x is less than 0, the square root of x squared is actually minus x. All right, let's look at that. So if I were taking this second equation, I see x squared, y, x minus x, y squared, y equals 30. Y squared, if y is negative, this would be minus y. So let's write this down. What do you get over here? Minus x root xy. Again, both x and y are negative. What do you get over here? Plus y root of xy equals 30. Let me go back. A really long problem, and Wells didn't see this either. This is the first equation. This is an equivalent equation if both x and y are less than 0. It's equivalent, all right? Now I'm going to say, looking at it, it's fairly simple to eliminate the root xy, and by that I mean, well, maybe we should do that, all right? Let me point out what I mean by that. You would have the root of xy would equal 11 minus x plus y. You get the idea? And then over here, what do I got? I'm looking at this. I factor out the root xy. And what would you be left off with? Minus x plus y. What's this thing equal to? This over here. Let me show you where that is. That's this thing over here. And what's left over there? Y minus x, that equals 30. All right? And again, it's tough. I'm not saying this was easy. It requires a tremendous amount of thinking and doing. All right? And then what? I don't know. I guess you have to do something, right? Let's see. I guess I multiplied it out, didn't I? And it becomes quadratic in y minus x. You can write that differently, by the way. And then use the quadratic formula in that. I'll point out what I mean by that. This is quadratic in y minus x. So if I were doing that, y minus x, that's the The variable part of it, it would be the coefficient. Let's see, the A would be, twice A would be 2. Then minus 11, plus or minus. It's really not bad to do, by the way. However, it's a lot of work. This is really going on for some time. Then when you get there, well, 121, and then plus, 4 times 30, 120. That's where the 241's coming from. Brutal. I mean, really a brutal problem. And certainly if you're getting this far, if you're listening this far, it's good for you. But I get this over here, then the bottom line, more brain activity. Actually, the brain's overheating at this point. You start to realize some things about it, and you got to go through a lot more work. But you'll eventually, all that work, you'll eventually get to these two numbers over here. Now, granted, I'm kind of poo-pooing what's there, but I did put all the work down there for the students motivated enough to read through that, and you'll get this over here. I also plotted that point. By the way, it's a nested root. You can unnest it. I don't think it's going to make it any better. All right? But anyway, I did plot that point, and in fact, that is the point I just plotted over there. How did I do that? I used a computer to compute those numbers, and I plotted that point. All right? This is an interesting problem, by the way. And again, I want to tell you that Wells got it wrong. Wells got this one wrong. I can't remember what answers he listed, but he didn't list the right answers to it. He didn't even list all the answers to it. I think he listed some correct answers to it, but he didn't list the answers that were appropriate. I mean, this appropriate answer, that's an appropriate answer, that's an appropriate answer. What's my advantage, though? I have tools. Wells did not. The tools he had were humans, and that was expensive. They couldn't have gone through that work to get that, all right? Did I go through the work to do it? Yeah. It was tough. I still used a tool to help me verify what I was saying was true. Thank you.